start a mathematics paper 2, whereby I will begin with the section 1. Then later I will be handling the section 2 in a different lesson. So for now, just continue joining us. Just join the lesson. So I'm going to start right away. I'm starting right away. This is one of the pre-mocks which was done in one of the schools in our country. Number 1, use logarithms. Use logarithms to 4 decimal places to evaluate. Then you are given a question there. Use logarithms to 4 decimal places to evaluate. So this is a question which needs a lot of order, a lot of organization. You don't just have to rush. And this is how we're supposed to approach a question like this. We're going to arrange everything in order. So I'll begin with the numbers. Then I'll go to the logarithms. Once you join, you can share the link with a friend. You will find everything here. You can first of all share the link with a friend, then you get back. So this is how I'm going to arrange my work. I'll begin with a number. Then the standard form. Then the logarithm at this end. We call it log. So that is how we organize the work. Remember, the question is open. We've been told to use logarithms, not strictly the logarithm tables. So sometimes they open the question, like in this case, use logarithms. Some other times they will tell you to use logarithm tables. In such a case, stick to the table. But for now, allow me use the logarithms in the calculator. Therefore, we have the first number here, which is 23.56. So the standard form is going to be 2.356 times 10 to the power of 1. Therefore, the time I will start doing the logarithm, I will start with the power here. So it will be 1 point. The logarithm of, in the calculator now, 2.356, which is a 0.3721. So will be 3722. Remember, we've been told to 4 decimal places, and it is what I'm going to stick to. That is the first number. The second number, which is 0.28, in standard form it will be 2.8 multiplied by 10 to the power of -1. This means now the logarithm will begin with the power here, and we don't write it as a -1. We write it as by 1 to show that the negative is strictly on the characteristic part alone, not on the whole logarithm. Therefore, now we can take the logarithm of 2.8. This gives us 4472. That is that is to 4 decimal places. So now, because this number has been raised to power 2, this number has been squared, we multiply the logarithm by 2. When a number has been squared, we multiply its logarithm by 2. Therefore, we can multiply the number here by 2. Remember, you're not supposed to use a calculator in this case in the multiplication. I'm just going to multiply manually. This will be 4. This will be 14. So a 4 carry 1. This will be 8 plus the 1, I'll have 9. This will be 8 point. This is bar 1, so it becomes bar 2 by 2. So I have solved the first number and the second number. And now, because that the first and the second numbers have been multiplied, then it means I should add their logarithms. So I will take the logarithm from the first number and the logarithm from the second number, then I add them. That is what I'm going to add, so that I may do away with the numerator completely. Therefore, I'm going to add the two logarithms, that from the first number and from the second number. Continue joining. Remember to share this broadcast link with a friend. So let me add the two logarithms. So I'm going to have 2 and 4, giving us 6. Then 2 and 4 again, giving us 6. Then we have a 7 and 9, giving us a 16. So 6, we carry 1. This will be 4 plus 8, giving us 4 plus 8, it gives us a 12. So 2, we carry 1. So you find now this is 1. So plus the 1 we've carried, it becomes 2 plus bar 2. So 2 plus bar 2 cancels to 0, because bar 2 is the same as negative 2. So this is the logarithm from the numerator. Then finally we have the denominator, which is 4329. 4329. So the number here is 4329. The standard form is going to be 4.329 times 10 to the power of 3, because we have 1, 2, 3, the power of 3, which means the log is going to begin with 3 point. Now we key in the logarithm of 4.329. This is going to be 6364. 6364. Now that we have the logarithm of the denominator, we are now supposed, because there is a division here between the numerator and the denominator, they have been divided. Therefore, I'm going to subtract the logarithms. The final logarithm from numerator and that of the denominator now, I'm supposed to subtract. Therefore, I carry out a subtraction here. 6 minus 4. This will give us a 2. 6 minus 6, a 0. 6 minus 3, we'll also have a 3. Then this is a 2 minus 6. Remember, 6 cannot be subtracted from a 2, so we have to borrow 1 here to make it 12 minus 6 to give us 6. Then we have already borrowed a 1. So whatever was a 0 now is bar 1, because we've borrowed 1. So we have bar 1 minus 3. It's like having negative 1 minus 3. Negative 1 minus 3. And that will give us bar 4. That will give us bar 4. Therefore, this is the final logarithm. Now, the other thing is the overall power here, which is a root 3. When we are carrying out a root 3, we divide logarithms by 3. We divide logarithms by 3. And now, in this case, the characteristic alone should be made such that it is divisible by 3, so that we may also divide the other part, which is a mandisa, also by 3 independently. Therefore, to divide by 3, the characteristic here should be divisible by 3 without a remainder. That means we should make negative 4 divisible by 3. That means we can borrow 2 to make it a multiple of 3. When we borrow 2 from a negative 4, it will become a negative 6. Then the other side, which is a 0.6302, we add the 2 that has been borrowed, so that the other side now becomes 2.6302. That is to mean the 2 we have borrowed to make negative 4 divisible by 3 is added to the mandisa part, which was 0.6302, now to become 2.6302. So now independently, this can be divided by 3, and this other side also by 3. Also by 3. Therefore, I'm going to have this one becoming by 2 now. Then point this other part, which is 2.6302, divide by 3 to 4 decimal places, it becomes 0.8767. 8767. So this is the final stage for the logarithms now. So we can now get the answer now. The number whose logarithm is this. That means we should go back to this step whereby from the logarithm now we go backwards, we get the standard form, and that means we should have 10 times negative 2. Since the logarithm has about 2, then it means there is a 10 power negative 2. Then now the anti-log of this value. Therefore, shift log of this value, and I'm getting 7.5289. 5289. So this is the antilog of this part. Then we have this power. Whatever is the characteristic in the logarithm side, for the standard form, it's the power. Then now we obtain anti-log because this is the log. The 0.8767 is the log. Now we get the antilog and it takes us to this number. Therefore, when we get to the number itself now, we will have to divide this by 100 because this is negative. So we will have it, okay, in standard form, it's already a correct figure, but now we need to get 0.075, then this will be 289, but remember it should be to 4 decimal places as communicated by the examiner. So the final answer should be narrowed down to 0.0753. So that is the final answer. This is the final answer. Thank you for joining. I can see we are increasing. Continue attending the lesson. If you didn't afford to begin with us, you can flash back and receive everything which has been handled. Whenever you carry out a question, whenever you carry out an operation using logarithms, it's important, it's good, it's advisable. You can confirm now the whole thing using a calculator. Let's check using a calculator what the value would have been if we had been given this to evaluate with a calculator. What could we have scored? So we need 23.56 multiplied by 0.28 squared. Then we divide by 4329. This gives us a 4.2668 times 10 to the power of negative 4. So that now we take the third root of this answer. This is giving us exactly 0.07528. So you see, the answer we had gotten is also being obtained in case we directly use a calculator to compute. So it's good you confirm yourself. Once you've done everything, just confirm. And the answers will not differ that much if you are accurate in using the logarithm. So that is how we balance. That's how we balance it and we confirm our accuracy. You can see to 4 decimal places, we have the same thing. We have the same thing. So that is how we handle the 4 marks. Continue joining. Thank you so much. Number two, make S the subject of the formula. So we got a formula here. Whereby we are supposed to change the subject of the formula to be S, and we can see S is inside here. So what you're going to do in such questions, we just maneuver until we bring S to one side. to one side. So we have a p multiplying everything here. We can start by dividing by p through, so that we have dp, d out of p, that is equals to, now we will have a square root of s squared minus w squared divided by r squared plus, I think this is a 5 squared, yeah. So we can have it as 25 because it's 5 squared. Then now that we have a square root sign here, we can do away with it by squaring both sides now. We can square this side and we also square this side, so that we have d squared out of p squared being equivalent to s squared minus w squared out of r squared plus 25. R squared plus 25. Remember, our intention is to remain with s alone. Therefore, we can multiply both sides with this denominator, so that we have this d squared out of p squared multiplying with r squared plus 25, r squared plus 25, then this is equals to s squared, this is equal to s squared minus w squared. At that point now, I can choose to remain with s squared alone by bringing the negative w to this other side. Therefore, at this side I will have d squared out of p squared into r squared plus 25. This is equal to, okay, the negative w now comes to this side, becomes a positive w squared. Sorry for that. This is equal to s squared. That is equal to s. That is equal to s squared. Therefore, now to remain with s, because we are having s squared, then we need to obtain square root of the other side. So we need the square root. We need the square root plus or minus the square root of this other part, d squared out of p squared into r squared plus 25 plus w squared plus w squared. So that is how we make s the subject in the formula. Continue joining. I can see people are joining our lessons. People are joining our lesson. This is encouraging. Continue joining. Okay, we have a number 3 here. We have a number 3. And number 3, which has to be handled now without using tables or calculators. Evaluate and simplify. Okay, this is a combination of several concepts. It might look like we are evaluating trigonometry, but this is basically SADS. The sine of 30 plus the sine of 45 divided by the cosine of 60 degrees minus 1. Therefore, these are called special angles, whose trigonometric ratios can be expressed in SAD form. And I want to show you how we work out their trigonometric ratios. Therefore, we can use an isosceles, okay, an equilateral triangle of 1, 1, 1. That means each angle is 60, 60, 60. A unit triangle a unit triangle which is equilateral. Therefore, in case we divide here, we will obtain 30. This becomes 90. Then now we can obtain this side, whereby we need 1 squared minus 1 squared minus because we've divided, this was also 1, we get now a half and a half. That means we have 1 squared minus a half squared, which gives us 3/4. So the square root of 3/4 will make the root of 3 unknown, but that of 4 is known to be 2. Therefore, we're going to have this side as the root of 3 out of 2. The root of 3 out of 2. That known, we have the 3 sides. So we can say the sine of 30, now that is here, will be opposite out of hypotenuse. The opposite is a half out of hypotenuse, which is 1. So it remains half. Something else we desire is the cosine of 60. So the cosine of 60, now that 60 is at this point, cosine is usually given by the adjacent out of hypotenuse, which still means half. It means half. Again, you should have known that the sine of 60 should be equal to the cosine of the sine of 30 should be equal to the cosine of 60. Actually, the half could have been concluded earlier. All right. The other thing is the sine of 45. So we can use a right-angled isosceles triangle. This is right-angled, 45, 45, such that we have 1 and 1. So this side, 1 squared plus 1 squared, the square root. This side will be the square root of 2. So because we have a 45 and a 45, we can get the sine of 45. So the sine of 45 is usually given by, remember, sine of an angle is given by opposite out of hypotenuse. So 1 out of the root of 2. 1 out of the root of 2. Now with the trigonometric ratios identified, we can substitute them into our question here. We're going to have the sine of 30 as half plus the sine of 45 as 1 out of the root of 2, then divided by cosine of 60, which is half, minus 1, which is a constant already given. So now we're going to have the denominator can be solved and it will give us half. The denominator is given as half. So we have half plus 1 out of the root of 2 divided by half minus 1. Sorry, it's negative half. Half minus 1. It will be negative half. Negative half. Therefore, now we can now divide each of the terms in the numerator by half. Can divide by half. That means to do away with this half, we can multiply by negative 2, by negative 2, and by negative 2. So this will become negative 1 plus this will become negative 2 out of the root of 2. Therefore, what we're going to have here is negative 1 minus 2 out of the square root of 2. And remember, when you are simplifying surds, it's not advisable to have a surd as a denominator. Therefore, it's advisable to work out the denominator. Remember, this is a 1, so we can work with the LCM of root 2 so that we have the root of 2 divided by 1 to remain the way it is, times -1. We will have negative the root of 2 minus the root of 2 divided by the root of 2, we get 1 times -2. So it remains -2. It remains -2. Therefore, we're going to have negative the square root of 2 minus 2 out of the square root of 2. So now we can multiply both sides with the square root of 2. We can multiply with the square root of 2 over the square root of 2, so that the impact is not influencing the value of the answer. We just want to do away with this one. So in the denominator we will have a 2 because it will be the root of 4. We will have 2, but in the numerator this becomes negative the root of 4, which is 2. So -2 minus 2 the root of 2. So this will be the final answer. This will be the final answer. Though everything can still be divided by 2, and we have a -1 minus the root of 2. A -1 minus the root of 2. Let's check another question. Let's check another question here. We got a number 4. Given the position vectors OA equals to 4i plus 3j minus 2k and OB as 3k minus I minus 2j, then we are told that point C divides vector AB in the ratio 3:-1. Find the magnitude of OC. Give your answer to 2DP. This means, first of all, we're going to find the coordinates of C. C divides AB externally. C divides AB externally. C divides AB externally. So we can have from the origin, let me begin by illustrating what we have here. This is the origin. We have a point A, we have a point B, then a C, which divides externally. When you see a negative ratio, it means the division is external. The division here is external. Make sure you are following keenly. This is for the Form 3 students who have covered Vector 2. This is also for the candidates who are waiting for the KCSE. You must be aware of this. Therefore, we have 3:-1. This means the divider, which is C, from A to point C, we have 3 divisions. Then from C to where B is, we get back 1 division, -1. Therefore, we have a total of 3. Then we go back 1 division. So we have 1 division here and 2 divisions here. So that we have a total of 3, then -1. That is how external division means. 3:-1. So from A to where C is, 3 divisions. Then backwards to B, we have a -1. Therefore, it's 1 division. Therefore, now the coordinates of A are given. This is 4, 8, -2. I'm trying to extract the coordinates as a column instead of the unit vectors. The next one will be 3 at B, 3, -1, -2. So that is what we have at B. But at C, it's not known. So at C, we'll have X, Y, Z. Let me use unknowns, X, Y, Z. Now, according to the ratio theorem, it is usually important for students to know that if this is a vector, this is another one, and this another one, then the dividing ratios are m:n. I want to express generally what we call the ratio theorem. In case we get the ratio at this point, which is n, okay, to get the coordinates of B, which is a divider to AC, in case we want to get the coordinates of B, we will need the ratio here, which is n, out of the total ratio, m plus n, and because we have used n, we multiply it with the opposite vector, that is A, plus we take M out of the total ratio, M plus N, then we multiply by, because we've taken M, the opposite vector, which is C, vector C. Therefore, for us to get B, which is already known, this is 3, -1, -2. For us to get this, we will need the ratio N, which is 1, out of the total ratio, which is 3, multiplied by vector at A, which is 4, 8, -2. Then we add the ratio at M, which is 2, out of the total ratio, which is 3, times the vector at C, which is unknown, X, Y, Z. X, Y, Z. So we are now going to find X, Y, Z. I'm going to begin with the X components, the Y components, then the Z components, and I will get each unknown. So I will equate 3 with a third times 4, making it 4 over 3, plus 2/3 of X, 2/3 of X, 2/3 of X. So I can get X now. I can get X by taking 3 minus 4 out of 3. Then now I'll have to multiply with 3 over 2. And this gives me 2.5. X is 2.5. The next is getting the value of X. Okay, X is obtained. Value of Y. So I go to the Y components and I will equate -1 with a third times 8, giving us 8 over 3 plus 2/3 of Y. Therefore, to get Y, I'll need to take -1 and I subtract 8 out of 3. Then now to remain with Y alone, I multiply with 3 out of 2, both sides, to remain with Y. This is giving me -5.5. The other one is to get the value of Z, whereby I love to equate the Z components. This is -2. So I'll equate -2. Let me use the space up here. I'll equate -2 with a third -2, which makes it 2 out of 3 negative, plus 2/3 of Z. 2/3 of Z. 2/3 of Z. Therefore, to remain with Z, I will need -2, and I add 2 out of 3. I add 2 out of 3, because when we take it to the other side, it will be added. Then now, after getting this, to remain, because we have 2/3 Z, I'll multiply with 3 over 2 both sides. So that the value of Z becomes a -2. A -2. Find the magnitude of OC. So the OC itself as a vector now. The OC itself as a vector. OC as a vector is going to be, we have X being 2.5. So we'll have 2.5 I minus 5.5 J minus 2K. That is the vector OC. That is the vector OC. Now with the vector OC, we can get its magnitude. To get the magnitude, then we will need the magnitude of OC. We will need 2.5 squared plus 5.5, which is a negative, squared. Then I also add negative 2 squared, then I take the square root to get the magnitude of this vector now, because we have the length OC. We have the vector OC given here. So to get the length, we just square each components now. We need 2.5 squared plus negative 5.5 squared plus negative 2 squared. Then now I carry out the square root. This will give us, remember we've been taught 2 decimal places, 6.36 units. So that is the length of vector OC. We can go to the next question very fast. Number 5. Can go to number 5. Number 5 is telling us, given that the values of P is 8.2, the value of A is 4.1, and the value of B is 7.0. They are all centimeters, and they were measured to 1 decimal place. Find the percentage error in the evaluation of, when we are evaluating K, this is K, sorry, I think there is a typing error. Yeah, K is 8.2. When we are evaluating K divided by A times B, the percentage error. This is on errors and approximations. So we are supposed to know the limits within which the recording of these values were done. It's 1 decimal place. Now that it is 1 decimal place, it means the absolute error in the recording was 0.1, which means for us to get the limits, let me work on this space. For us to get the limits of all these quantities, we need the limits of K, which will lie between, it's a 8.2, so we will add and subtract 0.1 divided by 2, which will be 0.05 for us to know the limits. And this will give us 8.15 up to 8.25 centimeters. The recording of A, the limits of A is 4.1. So it will be 4.1, the same accuracy. So we are adding the same absolute error. And the limits of A are going to be 4.05 all the way to 4.15. That is the limits of A. Then the limits of quantity B, which is already a 7.0, we're going to add the same 0.05. This will give us all the way from 6.95 to 7.05. So those are the limits of recording the several quantities. Then in this calculation now, in this evaluation, we will have what we call the actual value or the working value. The working value is usually given by, just as they were stated, 8.2 K out of A, which is 4.1, multiplied by B, which is 7.0. So this is going to be, we have 8.2 divided by 4.1 multiplied by 7. This is going to give us 0.2857. This is to 4 significant figures, so we can operate with that. And just have that. After actual value, we can go to what we call maximum value. Maximum value. For us to obtain maximum value in this evaluation, then we need the greatest value of k, which is 8.25, and we divide this by, for us to get maximum quotient, because we are dividing, then we should divide with the smallest value of a times b, which means we need the smallest values here, which are 4.05 and 6.95. 6.95. So we can carry out this multiplication. 8.25 divided by 4.05 times 6.95. This is giving us 0.2931 to 4 significant figures. The next, I'm going to get what we call the minimum value in this working. The minimum value. Now, for us to obtain the minimum value, it means we will need the smallest value of k, which will be 8.15. 8.15 divided by the greatest value on the denominator side. And the greatest value will be the greatest value of k, of a and b. Therefore, we will need 4.15 times 7.05, and this maximum value is going to be 8.15 divided by 4.15 times 7.05, and this is giving us 0.2786 to 4 significant figures. Therefore, we have the minimum value, we have the maximum value, and we have the working value, or rather the actual value. Therefore, there is something we should obtain here, and this is called absolute error. We usually take the maximum value minus minimum value out of 2. Maximum minus minimum out of 2. Maximum minus minimum out of 2. So we're going to have a maximum of 0.2931 minus 0.2786. We divide this by 2. 0.2931 minus 0.2786. Then we divide by 2. And this will give us 0.0012725. Yeah, 725. So this is what we are getting. Then now, finally, we have to get what we are calling percentage error. But before percentage error, we get what we call relative error. Relative error is usually obtained by absolute error out of actual value. Actual value. Therefore, we need the absolute error we have just calculated out of the actual value of the working, which is 0.2857. This is going to give us, when we divide by 0.2857, okay, I'm getting a 0.0254. Then after getting what we're calling the relative error, now we can wind up by getting percentage error. So percentage error is usually given by relative error times 100. Therefore, we just need to multiply this figure by 100 now, and we'll be there. This is 2.53 8 to 4 significant figures percent. So this is the percentage error. This is going to be the percentage error, the percentage error. So that is how we work it out. That is a question on errors and approximations. Kindly make sure you follow through closely. Make sure you follow through closely. We're going to the next question now. Going to the next question, whereby the question is on binomial expansions. Binomial expansions. So we've been told in this case to expand 1 minus half x raised to 10 up to the fourth term in ascending powers of x. Hence, evaluate the value of 0.95 raised to 10 to 3 decimal places. The first thing I'm going to show you is how to get the Pascal's coefficients of expansion. Remember, the first, continue joining. You can also invite a friend as we cover the lesson together. Thank you so much. Okay, we're going to look at the binomial coefficients of power 10. We can just begin with power 2. When the power is 2, we usually get 3 terms after expansion. When you expand a quadratic binomial expansion, you get 3 terms, and their coefficients are 1, 2, and 1. When the power is 3, you get 4 terms, and their coefficients are given by 1. So we start with the 1 here, then 1 plus 2, we get 3. This gives us 3, then we drop 1 here. So these are the coefficients for power 3. For power 4, we will have to start with 1, then we add again. This is 4, this will be 6, this will be 4, this will be 1. Then we go to power 5, we start with 1, this is 5, this is 10, this is 10 again, this is 5, and we drop 1 there. For power 6, we begin with 1, then this is a 6, this is a 15, this is a 20, this is a 15, this is a 6, we drop 1 at this point. The powers of 7, the coefficients of power 7, we're going to begin with 1, then we have 7, 21, 35, 35 again, 21, 7, and 1 at this point. So now with 1, 7, 21, 35, 35, then 21, 7, and 1. These are the binomial coefficients of power 7. We can go to power 8, whereby we need to begin with 1, then we add this to get 8. The next will be 28. The next here will be 56. Yeah. The next here will be 70. This will be 56. This is going to be 28. This is going to be 8. Then 1. Thank you. I can see you are still joining the lesson. Continue joining. The binomial coefficients of power 9, are going to be, we can start with 1, then 9. This is going to be 36, yeah. Then 28 plus 56, we're going to have 84. Yeah, I think this is 84. When we add 28, yeah, 84. Then we will have 70 and 56, giving us 126. Then again 126. Then this is going to be 84. This is going to be 36. This is going to be 9, and finally 1. We have now the powers of 10 according to the Pascal's triangle. The powers of 10, we're going to start with 1, then 9 plus 1, which is 10, 9 plus 36, giving us a 45, then 36 and 84, 36 and 84. Just to increase my accuracy, this will be 120. This will be 84 and 126, giving us 210. This is 210. Then 126 plus 126, this will give us 252. Then this is 126 by 84 to give us a 210. 86 and 36 to give us 120. 36 and 9 to give us a 45. 9 and 1 to give us 10. Then 1. So these are the binomial coefficients of power 10. We are now going to use them in the expansion here. Expand up to the fourth term. Up to the fourth term. Expand up to the fourth term. So we just need the first 4. We just need the first 4 in this case. Expand up to the fourth term. So we need the first 4 binomial coefficients or Pascal's coefficients of power 10. And the first 4 are 1, 10, 45, and 120. Therefore, we will have 1. We begin by listing the coefficients up to the power which has been instructed. So we've been taught to the fourth term. So the first term will have a coefficient of 1, the next a coefficient of 10, the third a coefficient of 45, then the fourth a coefficient of 120. That is to the powers of 10. To the powers of 10. That means now we can begin expanding. Remember, we are expanding 1 minus half x. So we'll start with 1. Yeah, sorry for the inconvenience. So we're going to have in the next term, now 1 drops to power 9, and the negative half x takes a power 1. It takes a power 1. In the next term, we shall have 1 dropping to power 8, but negative half x increases to power 2. Then finally, here at 120, we will have 1 dropping to power 7, the negative half x increasing to power 3. Negative half x increasing to power 3. So in the first term, we'll have 1 times 1 raised to power 10. 1 raised to anything remains 1. So we will have this becoming 1. Then anything raised to 0 becomes 1. So this is just 1. So we're going to have in the whole first term just 1 like that. In the next term, whereby it's 1 power 9, it remains 1 times 10. Then negative half x power 1 remains the way it is. So we will have 10 multiplied by negative half x. It means the 10 will be affected by this half to make it a negative 5, then x, which is to power 1. In the third term, we will have 1 power 8 remaining the way it is, but now negative half x power 2 will be affected. The negative half becomes positive a quarter, and x becomes squared. So we will have 45 times a quarter x squared. 45 times a quarter, or 45 times a quarter, yeah, which will mean 45 out of 4, and x is squared. Then finally, the third term, remember we have 120, 1 power 7 remains 1. Then we have negative half x to the power of 3. So it becomes negative 1 over 8 x power 3. So 120 in this case is being divided by 8, and it gives us 15. But remember, there is a negative 15. X is to the power of 3 in this case. Therefore, we have now expanded. This can be given as a proper fraction. Then now we had been told by the examiner to do what? To use S evaluate the value of 0.95 raised to the power of 10 to 3 decimal places. To 3 decimal places. For us to evaluate, we have to equate the two parts. we have to equate 1 minus half x raised to 10 with 0.95 also raised to 10. If they are equal due to the powers, then it means the bases are also the same. 1 minus half x is the same as 0.95. If this side raised to power 10 equals to this side raised to power 10, then it means the bases are also the same. So to remain with half x, we need 0.95 minus 1 to give us negative 0.05. And the negatives cancel. To remain with x, we should multiply by 2 both sides. This gives us 0.1. Therefore, in the expansion now, wherever we have x, we substitute 0.1. So we're going to have, in this expansion, wherever we have x, as 0.1. Therefore, I'm going to begin with 1 minus 5 into 0.1 plus 45 out of 4, 0.1 squared minus 15, 0.1 raised to power 3. Raised to power 3. Yeah, that's how we handle the binomial expansion. Now we can key into the calc exactly the way we are having it. The expression 1 minus 5 into 0.1. Then we add 45 out of 4 to 0.1 squared. Then we subtract 15 into 0.1 cubed. So this is going to give us 0.5975. Remember, this is to 4 significant figures, but the examiner is instructing us to 3 decimal places. Therefore, to 3 decimal places, we're going to have 0.598. This is accurate. This is accurate to 3 decimal places. In case we carry out 0.95 raised to power 10, we are getting 0.598. 598. And when we truncate to 3 decimal places, we are still correct. So our expansion is accurate. Our expansion is accurate. We can go to the next question, which I see it's a question in Form 3 on mixtures. A question on mixtures. You can invite a friend as we continue. We're going to be here. So odd on, I'm getting. Yes. Thank you for your patience. Thank you for your patience. We can now continue. We can now continue. At number 7. At number 7, whereby the question is from mixtures. We've been told that 2 types of coffee, grade A and B, retails at 240 Kenya shillings and 300 Kenya shillings respectively. Mohammed sells a mixture of both grades at 303. This is and 6 cents, making a profit of 10%. Find the ratio in which he mixed the grades. Find the ratio in which he mixed the grades. So the grades have been mixed in a certain proportion, which we don't know. But in that mixing, there was obtained a mixture such that if the mixture is sold at 303 and 6 cents, the profit is 10%. That means we can guess the price of this kilogram of a mixture without the profit. How much is this kilogram? If there is a 10% profit, it means this is 110%, which is costing 303 and 6 cents. So we can get 100%, which will be the price of a kilogram without the profit being realized. 303 times 100 out of 110. So this is going to be when I multiply 303.6 by 100, then I divide by 110, I'm going to get 276 Kenya shillings. Therefore, this trader, Mohammed, mixed the two grades of sugar now, the one costing 240 and the other one 300, so that the kilogram of a mixture is costing 276. That is why 303.60 cents is giving a profit of 10%. So we had to calculate the cost of a kilogram now without the profit. The next thing is to get the ratio into which they were mixed. I want to show you the simplest way into getting the ratios. So what we do is we need to take the first grade, which is A, the other grade, which is B. The price of A is 240. The price of B is exactly 300. And the mixture, we place it at the center here, 276. Then we subtract now 240 and 273. And we are getting 36. We also have to subtract the other side, 300 and 276. And we are getting a 24. Therefore, the ratios into which they were mixed is 24 is to 36. We can have the simplest expressions of this ratio. 24 is to 36. 6 is common. So we can have by 6, 4. And by 6, we're going to have 9. So 4 is to 9 is the simplest ratio into which the two grades were mixed. Alternatively, we can say we are mixing. We can say that, let me focus well. Yes, alternatively, we can say that we are mixing some kilograms of A and those of B. So we can say the cost price by 6, this is a 4, and by 6 we also get a 6. That means we can divide further. Actually, we could have divided by 12. So this simplifies to 2 is to 3. The simplest ratio is 2 is to 3. But alternatively, we can get the same values. By working it out differently. We can say we are taking 240 of a grade, and we mix, let's say, A kilograms. And we also take 300 times B kilograms. Then because these are A kilograms, B kilograms, for us to get the cost of 1 kilogram, we need to get the price of 1 now, is A plus B. And we are saying this is giving us 276. So now we can cross multiply with A plus B, so that we have 240 A plus 300 B. This is equal to 276A and 276B when we cross multiply with this. Therefore, we can group like terms together, whereby we can bring B's to this side. 300 minus 276. This will give us 24B equals to 276 minus 240, 36A. Therefore, now to remain with A out of B, to remain with A at this side over B, then we need to bring the 36 here because the B has gone to this side. So we will have 24 out of 36. In the simplified form of 24 out of 36, we will have 2 out of 3. So if A out of B is 2 out of 3, then it means the ratios of A is to B will be 2:3. So that is how we get the ratios. You can work it out this way, or simply you subtract as we did in the first approach. We continue. We are told that Juma, a Form 2 student, was told to pick two numbers, X and Y, from a set of digits 0, 1, 2, 3, 4, 5, and 6. Find the probability that the absolute value of X minus Y is at least 3. That means this individual, Juma, a Form 2 student, is taking the digits and carrying out subtraction. So we want to know the difference between X and Y is giving us at least 3. This is a question on probability, and we're going to use what we call a probability space. Therefore, I will draw a probability space in this case, whereby I will list the numbers X and Y. I'll list the numbers X and Y such that they are, this is 1, 2, 3, 4, 5, 6, 7. They are 7 numbers. So I will need 1, 2, 3, 4, 5, 6, 7. So that for X, these are X. If I begin with 0, 1, 2, 3, 4, 5, 6, then the others, which are Y's now, they're also going to be the same. 1, 2, 3, 4, 5, 6, and 7. 6 and 7. Therefore, for Y's, I'm going to have 0, 1, 2, 3, 4, 5, 6. So these are the digits. We have the Y's and the X's. When I pick a Y and a X, I carry out subtraction. So 0 minus 0, I get 0. 1 minus 0, I get 1. 2 minus 0, I'll get 2. 3 minus 0, I'll get 3. This will be just as they are. Then the next now will be 0 minus 1, giving us negative 1. 1 minus 1 will give us 0. 2 minus 1 will give us 1. 3 minus 1, 2. So they will follow one another like that. In the next, I'll have 0 minus 2, giving us a negative 2. 1 minus 2, giving us a negative 1. 2 minus 2, giving us 0. 3 minus 2, giving us a 1. They continue increasing in that order. Then I will begin with 0 minus 3, a negative 3. Then 1 minus 3, a negative 2. 2 minus 3, a negative 1. 3 minus 3, a 0. 1, 2, 3. So you just have to understand the trend in this case now. The next, we will have 0 minus 4, giving us a negative 4. 1 minus 4, a negative 3. So we'll go to a negative 2, a negative 1, a 0, 1, 2. 0 minus 5, a negative 5. A negative 4, a negative 3, a negative 2, a negative 1, 0, 1. Then finally, 0 minus 6 will be a negative 6, negative 5, negative 4, negative 3, negative 2, -1, 0. So those are the possible differences when we pick a number for x's and a number for y's. Then I carry out subtraction. So these are all the possible outcomes listed in the probability space. Now we are finding the probability that the difference, the absolute difference, when you are told x minus y like this, it means it's the absolute difference, whether 3 or a -3. So we want it's at least 3. So 3 and above. 3 and above. 3 and above. Remember, the outcomes are 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6, 7. So the outcomes are a total of 49. 7 by 7. The outcomes are 49. But now we want the cases whereby the difference is at least 3, the absolute difference, at least 3. So 3 and above. When we talk of at least 3, we mean 3 and above. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10. And because we want absolute value, we also consider the other side. It can be a -3 and above. So the negative values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So another 10 from the other side. So we have 20 possible outcomes, 20 favorable outcomes out of 49 possible outcomes. So the probability that the difference, the absolute difference between x and y equals to at least 3 will be 20 out of 49. 20 out of 49. That is the probability. That's how we do it. We can go to number 9. We are purposing to at least finish the session 1 in this paper. So kindly be patient. Be patient. We're going to finish it very soon. Two quantities, x and y, are such that y varies partly. This one has not been written well. This is partly. So y varies partly as the square of x and partly inversely as the square root of x. So we can first of all change this statement now from English to mathematical. Partial variation. So we are dealing with partial variation in this case, all right? Partial variations. You should know that in partial variations, we deal with two constants. So the two quantities are such that y varies as the square of x, so as the square of x, and partly, so we add, because the other part now, inversely as the square root of x, inversely 1 out of the square root of x. This means now we can do away with the constant of the symbol of proportionality, and we introduce two constants. So we're going to have y being equal to a constant like k times x squared plus another constant times this part. We can have a constant like c out of the square root of x. So we can include that where k and c are constants. Must know what is happening. Those are two constants. Now we can read more information on the same. Given that when x is 4, y equals to 40. When x is 4, y equals to 40. So 40 equals to x equals to 4. So 4 squared becomes 16 times k plus c out of the square root of 4, which is 2. So we can have this one as equation 1. We are told more that x equals to 1 when y is 18. So 18 equals to, we are substituting in this equation, 1 squared, it remains the way it is, plus c out of the square root of 1, which is still 1. So this becomes equation 2. So now we can solve the two equations simultaneously so that we may find the two constants, because we cannot proceed unless we first of all get the two values of the constants we are using. So we can use a substitution method here, because from the second equation here, we can substitute the value of k as 18 minus c. 18 minus c. That means now we can rewrite equation 1. This is from equation 2. From equation 2, which means equation 1 can become 40 equals to 16, and instead of k, we have 18 minus c, yeah, plus c out of 2. So this will be 40 equals to, we have 18 by 16, giving us 288. 288 minus 16c plus half c. This is 0.5c. 0.5c, yeah. So we can talk of now negative 16 plus 0.5 giving us negative 15.5c. So we have 40 equals to 288 minus 15.5c. 15.5c. So we can have the value of c by taking 288 to this side, whereby we'll have 40 minus 288. Then now we divide through by 15.5, because the negatives will cancel. This will give us exactly 16. So the value of c equals to 16, which means the value of k can be obtained by 18 minus c. So this will be 18 minus 16, giving us 2. This means, because we are finding the value of y when x equals to 0.25, we can first of all write the general equation connecting the two. The general equation is going to be, the general equation is here. So y equals to k, which is a 2, x squared plus c, which is a 16, out of the square root of x. The square root of x. So that is the general expression connecting the two. That means we can find y given x, and we are given x as 0.25. That means y will be 2 into 0.25 squared plus 16 out of the square root of 0.25. Therefore, now we can carry out this computation and we get the value of y. We can carry out this computation. So we're going to have 2 into 0.25 squared, 2 times 0.25 squared, 2 multiplied by 0.25 squared. This gives us a 0.125 plus, we will have a 16 divided by the square root of 0.25. This gives us 32. So when we add, we're going to have 32.125. Make sure you follow closely. We are also having other lessons in the channel on variations, not only partial variations, but also joint variation, inverse variations, and more questions. Kindly make sure you follow. That was a number 9. We can check number 10 in this case. Can check number 10. Can check number 10. Can check number 10. In a triangle ABC, AB equals to 7.2, AC equals to 6.8, and angle BAC equals to 120 degrees. Calculate part 1, the length of BC to 3SF. That is 3 significant figures. Then we are also going to find if a circle passes through the vertices A, B, C, find the radius of the circle. Find the radius of the circle. Okay, we have going to have a circle here, then a triangle inside, then a triangle inside. The triangle is ABC, so you can have A, B, C. The given lengths are AB 7.2, AC 6.8, so 6.8, and one angle BAC. BAC. This is 120. We're going to find the length here. For us to find the length, we should apply what we call the cosine rule. The cosine rule. It should be noted that if this angle is A, the opposite side is usually called small letter A. This angle is B. The side here will be small letter B. This angle is C. The opposite side will be small letter C. And generally, to state the cosine rule, it states that when we take A squared, we should get the same as B squared plus C squared minus 2BC multiplied by the cosine of the angle at A. That is the cosine rule. So now we can substitute. Remember, the only unknown in this case is the length A, which is opposite to the angle A. A squared is going to be B squared is 6.8 squared plus 7.2 squared minus 2 into 7.2 times 6.8, the cosine of 120, the cosine of 120. Therefore, we can get the value of A squared, the value of A squared, 6.8 squared plus 7.2 squared. This is giving us 98.08. There's something I want us to notice, that this is a negative 2 ABC, but the cosine of this angle, which is in the second quadrant, is going to be negative. So this negative due to the cosine of 120 will affect the negative here. So we will end up adding. We will end up adding. So the cosine of 120 is a value which is negative. That is something very critical. Cosine of 120. Yeah, so we're getting negative 489.6, which means the negative 489 will affect this negative and it becomes a positive 489.6. That means the value of A squared equals to, when we add 98 now to this 0.08, this will be 98.08 to 489.6. This gives us 587.68. So the value of A will be the square root of this value, which is 24.24, but we are doing it to 3 significant figures, so it will be 0.2. Yeah, that is the length. Those are 3 significant figures according to the instructions. If a circle passes through the vertices A, B, and C, find the radius of the circle. We usually say that twice the radius of the circle, which circumscribes a triangle, twice the radius is equal to the sine rule. And sine rule we can use okay, we have a provided angle, so we can use the opposite length here, which has been gotten, length A out of the sine of A. Yeah, length A out of the sine of A. It can also be equal to length B out of the sine of B. It can also be length C out of the sine of C. But in this case, we can say that 2 radius equals to A, because it is only in this case whereby we both have the length and the angle. So it will be 24.2 divided by the sine of 120. So we are going to have twice radius being equal to answer divided by the sine of 120. This gives us 27.99. So radius will be, when we divide by 2, this gives us a 13.996, which means in case we make it 4 significant figures, it will be exactly 14.00 centimeters. So that is how we get the radius, by using the sine rule. We can continue to number 11. We are winding up. Number 11. The table below shows income tax rates in a certain year. The monthly income is as given the tax rates in each Kenya shillings. These are percentages: 10%, 15%, 20, 25, 30%. Then the incomes are just as shown. Now we are given some information here that in that year, Mr. Mogaka gets a total deduction of 5,000 Kenya shillings. He also gets a personal tax relief of 1056 Kenya shillings, and he pays 3944 for NHIF, then for WCPS, and also loan repayment. Calculate part 1, payee. Remember, we have been given what we are calling total deductions. We've been given what we call total deductions, and it's good to know that total deductions comprise of payee, which is the first deduction, plus other deductions. Therefore, total deductions for this guy are 5,000. We don't know the payee, but we know other deductions. So this guy pays 3944 for NHIF, for WCPS, and also for a loan repayment. So we have other deductions. The payee is unknown, but we know total deductions. So we can get the payee for this individual. So the payee is going to be 5,000 minus 3944. This gives us exactly 1056. Kenya shillings. So the payee is 1056. Now, the other thing we should calculate is monthly income, or rather, the monthly salary. Remember, we have the payee. So the other thing we should get is what we call the gross tax. We first of all have to get gross tax. And gross tax is when we add relief to the payee, because payee is the tax where relief has been deducted. So to get the total tax, or rather the gross tax, we need 1056, which is the payee, and we add the 1056, which is the relief given to this guy. Therefore, we're going to have it as 2112. So this guy has a gross tax of 2112 Kenya shillings. Therefore, for us to get his monthly income, then we are going to tax a known amount. This is a back taxation. We're going to tax a known amount until we get 2112. We tax a known amount until we get 2112. Therefore, here is the table. We have the first 9681. So we can have in the first bracket, we have a 9681 at the rate of 10%. This gives us 968.1. We go to the next bracket, whereby for the next bracket, we will need 18801 minus 9681. This gives us 9120. So we are taxing 9120 at the rate of 15%. This will give us times 15%. This will give us 1368.0. When we try to add this to 968.1, we realize that we are exceeding the total tax for this individual. That means the tax for this guy will end in the next bracket. So it means in this bracket, we don't tax the whole amount. So we can do away with this bracket and we introduce a known value at the rate of 15% to give us the remaining tax. So that is total tax. When added, we get 2112. So that means we need to get 2112 minus 968.1. And we will know that we have a missing 1143.9. Therefore, there is a certain value which is taxed at the rate of 15% to give us 1143.9. So that the total tax for this gentleman becomes 2112. Therefore, now we can get their non-tax, which at the rate of 15% gives us 1143.9, and it can be evaluated. So to get X, we need to multiply by 100/15 both sides. This will give us 7626. Therefore, X equals to 7626. Therefore, the amount that is taxed to give us 2112 is 9681 and 7626. So that the taxes are as shown for them to total at 2112. Therefore, what we are calling now the monthly salary, for this individual is going to be 9681 plus 7626. This is going to give us 17,307 Kenya shillings. So that is how the question on back taxation was supposed to be approached. Thank you for following. We are going to number 12. Remember, we are finishing up. We are at number 12. The questions are just 16. So we are winding up. Hold on. Continue being patient. Until we finish. So number 12, given that the matrix 3x, x, x minus 6, and negative 3 maps a triangle with the given coordinates onto a straight line, find the possible values of x. When you have been told that it maps a given triangle into a straight line, it means the object area, you know, the object has a certain area, but now the image we are getting has no area. So area of image equals to 0 because it's a straight line, equals to 0. And we know very well that the area of the image and that of the object, when they are related, they give us what we call the area scale factor. This means in this case, area scale factor equals to 0 because area of image out of their known area of object will definitely become also 0. So the language here to be understood is onto a straight line. When you understand what it means by onto a straight line, you will get to know that the area of the image is 0, meaning that area scale factor is also 0. This is to mean that now, because area scale factor is usually given by the absolute value of the determinant of the matrix involved in a certain transformation, then it means the absolute value of the determinant for this matrix is also 0. So if that is 0, then we can express determinant for this matrix and we get the values of x. Therefore, product of elements in the leading diagonal, which is negative 3 by 3x, minus product of elements in the other diagonal, x by x minus 6, should give us a determinant which is equal to 0. So this means negative 9x minus x squared positive 6x equals to 0. Yeah, these are positive 6x equals to 0. So we can arrange our equation so that we begin with x squared. This becomes negative 6x, then positive 9 to remain with a 0. So we have our quadratic equation now, which can be solved in several approaches. We can approach it using factorization, using completing the square. We can also use the quadratic formula. Let me use the factorization. We need a product of a times c, 1 times 9, and a summation of the value at b, negative 6. This means this is a negative 3 and a negative 3. Because when multiplied, they give a positive 9 added negative 6. Therefore, because the factors are the same here, it means this is what we call a perfect square, whereby the roots of x is just 1. Therefore, we'll have x squared minus 3x minus 3x positive 9 equals to 0. This is x. We factor out whatever is common in any two factors. So this is x. We remain with x minus 3. We factorize negative 3. So that we remain with x minus 3 equals to 0. Therefore, x minus 3, which is common, and also x minus 3 to give us 0. To give us 0. Therefore, x minus 3 equals to 0, and the value of x becomes 3. Therefore, the value of x in this question is only 1, and that is 3. Even though the equation is quadratic, it's a perfect square. It's a perfect square whereby the roots of x is only 1. Is only 1. Therefore, we can get to number 13. The third, 10th, and the 42nd terms of an AP form the first 3 terms of a GP, geometric progression. If the common differences of the AP is 3, find the sum of the first 10 terms of the GP. There is something we should understand about APs and GPs. Okay, they are both progressions, but the first one has a common difference, while the other one has what we call a common ratio. Therefore, second, 10th, and 42nd terms. How do we get any of the term? Any of the term. for an AP arithmetic progression, we need first term plus n minus 1 multiplied by d, which means the second term will be given by a plus n minus 1, 2 minus 1 multiplied by d, which means the second term will be a plus d. The third term is going to be, not third but 10th, a plus 10 minus 1 into d, which means the 10th term will be a plus 9d. And finally, we are having the 42nd term, a plus 42 minus 1 multiplied by d. This gives us a plus 41 times the value of d. The good thing is that the value of d is known in this case. If the value of d is known, it means these values can be re-expressed now to be a plus the value of common difference for the AP is 3. So it will be a plus 3. The next term will be a plus 3 by 9, giving us a 27. Then a plus 41 by d, which is a 3. This gives us 123. So now these terms, which are respectively second, 10th, and 42nd, they become consecutive for a certain GP. And in a GP, there is what we call a common ratio. This means that the three terms are giving us a common ratio, in that when this second term, you know, it is 10th there, but here it becomes second. It is 42nd, but here it becomes the third, because they follow one another as the first, second, and third. So it means a plus 27 divided by a plus 3 should just be the same as when we take a plus 123 and we divide by a plus 27. It's just the same because they give a common ratio because they are consecutive. Since they are consecutive, they should give a common ratio. Therefore, I'm right to have that expression. We can cross multiply, whereby a plus 27 will be multiplied by a plus 27, and it becomes a plus 27 squared. So it will be a plus 27 squared. Yeah, let me be slow. So in the next step, we are also having a plus 3 multiplied by a plus 121. So I can begin with a times everything here. A times a plus 123, then plus 3 multiplied by, again, everything, a plus 123. That's how we expand a quadratic expression. This is going to be a squared plus a times 27 times 2. Going to get 54a plus 27 squared, which gives us 729. This is equal to, this side we can open brackets, we will have a squared plus 123a plus 3a plus 123 by 3, giving us 369. So we can now group like terms, whereby a squared and a squared will cancel, because when we group it, we'll bring it to this side and a squared will cancel. Then we will have now 729 minus 369. This gives us 360, sorry, equals to, we have 123 plus 3, but we will subtract a 54 now, which is on the other side. This gives us 72a. So to get the value of a, we need 360 divided by this value, and we get the value of a as 5. The value of a as 5. Kindly make sure you follow through, understand every step as we have outlined it. So the value of a, which means the first term in the AP, is now 5. Now that A is known, we can get now the first term for the GP. So for the GP, we will have the first term. The first term is A plus 3, which means 5 plus 3, giving us 8. The next term is going to be A, which is a 5 plus 27, giving us 32. The fourth is going to be 5 plus 123, giving us 128. So that is how the terms follow one another now for the GP. So it means we can get the common ratio for the GP. 32 out of 8, they give us 4. We can confirm by getting 128 out of 32. We also get 4. Therefore, the common ratio is 4. The first term is 8 for the GP. Now we've been told to find the sum of the first 10 terms. The sum of the first 10 terms. Let me work it out here. It should be noted that the sum of a given number of terms is usually given by A into R raised to n minus 1 divided by R minus 1. This is strictly when the value of R is greater than 1. Actually, the absolute value of R is greater than 1. This means now we're going to have the first term for the GP, which is 8 into R, 4, raised to 10, because you're finding the sum of 10 terms, then minus 1 divided by 4 minus 1, which is our R. So we can compute this thing now. We will have 4 raised to 10. This gives us a very big number, minus 1. Then we multiply it by 8. Then after multiplying by 8, we divide by 3. We divide by 3. This is going to give us exactly 2,796,200. I've used my calculator. So that is the value you should arrive at. That is the value you're supposed to arrive at. Thank you for following. Continue following. Raw data collected from experimental observations normally have errors. Below is a table of results obtained from an experiment. The results show the length of a metal rod, how it varies with increase in temperature. So we have temperature increasing in degrees Celsius, and we have the length in centimeters of a metal rod. Then you've been told to plot the values in the graph below and draw the line of best fit. It has to be known that for us to have a line of best fit, it has to accommodate the line of best fit when you plot. Okay, the data on the graph will just be suggesting a straight line, not a perfectly straight line. That's why we are saying line of best fit. Therefore, you ensure that the line of best fit accommodates majority of the dots. And again, once you plot such a graph, also ensure that the dots which do not agree to be on the line are left on above the line and below the line. Leave the dots which do not agree to be on the line below and above the line. What I'm trying to mean is that if a line of best fit has been drawn, don't have the dots which are not agreeing, all of them being below the line or all of them being above the line. At least if a line of best fit has been drawn and we had dots here, the line should pass such that if this dot is not on the line, the other dot which is not on the line is on the lower side, not all the dots being on the same side of the line. So make sure you observe such rules whenever you are drawing the line of best fit. The line of best fit. Then as we come to the end, as we come to the end, we have a number 15 here, and number 15, which talks of evaluate the value of x in the following trigonometric equation. Therefore, we have the sine squared of 2x, which is equal to 0.25. Therefore, what we're going to do first is to do away with the coefficient of sine squared of 2x. This makes it, we multiply 2 by 2 both sides to have the sine squared of x of 2x being equal to 0.5 when you multiply through. And because this is sine squared, then we can say the sine of 2x. Because this is sine squared of 2x, then the sine of 2x is going to be, we take square root both sides. The square root of 0.5. This gives us 0.7071. Because this is sine squared of 2x, then the sine of 2x will be the square root of this other side. Therefore, for us to get the value of 2x, then we need the sine inverse. Shift sign of this value, and we are getting exactly 45. We are getting exactly 45. Exactly 45. This is to mean, okay, there are some other angles where the value of sine is positive, and that can be in the second quadrant, because we usually say that if this is all of them here, all the trigonometric ratios are positive in the first quadrant, sines, tangents, and cosines. It is only sines which are positive here. So it means we also need an angle of 45 in the second quadrant. An angle of 45 in the second quadrant is going to be 180 minus 45. This gives us 135. Therefore, 135 will also give us the same. Then in case we make a complete cycle, 45 in the next cycle becomes 405. That means when we start dividing by 2, that value will go beyond the given range. Therefore, the values of x can be given by 45 out of 2, which is 22.5 degrees, and 135 out of 2, which is 67.5 degrees. So these are the two angles. Finally, number 16. Remember, we are winding up. The final question in session 1. The points with coordinates, we have A, 13, 3, and point B, negative 3, 9 are the ends of a diameter of a circle, center O. Determine the coordinates of center O. Okay, we are on the equation of a line, or equation of a circle, sorry. But in this case, there is another concept which has been brought into place. And that is vector 2, the midpoints of a given line. This is the center. Then the end of a diameter, we have A and B. The center, which is, the center of the circle, will be the mid of the diameter. That means we need to calculate the mid of coordinates A and B. That means we need to get the first x and the second x. That will mean 13 plus negative 3, and we divide by 2, comma, the first y, which is 3, the next y, which is a negative 9, and we divide by 2. This is going to give us 13 plus negative 3 gives us 10 over 2, which is 5. 3 minus 9 gives us a negative 6 over 2, negative 3. Therefore, 5, 3 is the coordinates of center O. The coordinates of center O. The coordinates of center O. Then now we are told to determine the equation of the circle. The equation of the circle, express it in the form x squared plus y squared plus ax plus by plus c. The other thing we should get in this case is the radius of the circle. The radius of the circle. So the length between the center and either B or A. In other words, we can also get the length from A to B and we divide it by 2, the length from A to B. But in this case, we can just get the length from the center to B, for example. So let me use the length OB, which means I'll get B, which is -3, -9, and I'll subtract center of the circle, which is 5, -3, and this is going to give us a -8. This is going to give us a -9 plus 3. We get a -6. We get a -6. Therefore, for me to get the length of this vector now, I'll need to take -8 squared plus -6 squared. Then I take the square root. This becomes a 64 and a 36. 100. The square root of 100 becomes 10 units. It becomes 10 units. So the radius of this circle is 10 units as obtained there. 10 units. So with radius and the center, we need to say that we need now x minus a, which is the x coordinate of the center. This is 5, and we square, plus y minus the y coordinate, which is b. Y minus b. This is the y coordinate of the center. So y minus a -3, it becomes positive 3. We also square. This is equal to the radius of the circle squared, which is 10 units. We also square. Therefore, now we can expand these expressions, and we're going to have x squared minus x times 5 times 2. We get 10x plus 25, plus we have y squared plus y times 3 times 2, we get 6y, then plus 3 squared, which is a 9. This is equal to 100. Now with this, we can arrange the equation as it is desired. So we need to begin with x squared, y squared, then the value with x, which is -10x, then the value with b, the value with y, which is a 6y, then the constant. Now remember, we are having 25 and 9 giving us a 34. Then we bring 100 to this side, so 34 minus 100, this gives us -66. So instead of addition, we have a -66, and we remain with a 0 at this side. So that is the equation. That is the equation of the circle in the desired format. Thank you very much for following. Subscribe and share.